Okay, adding, subtracting fractions and rational expressions aren't all that different. It's just like when I were to add these fractions down below, I need a common denominator. And I'm going to look at, here we go, 2, 4, and 6. I know that I could come up with a common denominator by multiplying 2, 4, and 6, and that's going to be 2 times 8, so what, 6, 48? That's kind of big. But like I could use that if I necessarily need to. Instead, what I could do is find the lowest common denominator, which would be 12. So to make this into a 12, I'll multiply the top and the bottom by 6, the top and the bottom by 3, the top and the bottom by 2. So 6 over 12 plus 9 over 12 plus 10 over 12. My final answer is going to be over 12 by taking the numerators and adding them all up. So 19 plus 5, 25 over 12. And you can leave it just that. So here we go. Let's try it with rational expressions. If there already is a common denominator, so it's all over 2x, I'm just going to take 3 minus 7, which is negative 4. Now that I get to that point, I notice that 4 and 2 are both divisible by 2, so I divide them up by 2, and I get negative 2 over x. Reduce after you add or subtract, okay? Don't do it before. You're going to ruin your common denominator. Like here, I've got a common denominator. Both polynomials or both fractions have a common denominator of x minus 4. Add the tops, and I've got 3x plus 6. They're not like terms, so I'm not going to add them together, so I'll leave it as is. Okay. All right, simple enough when I've got a common denominator. Here, I do not have a common denominator, but to find my common denominator, factor the denominators first. And the reason why I say that is here, the first one's 3x to the third. The next one, I can take a 3x squared out of both. So 3x squared, and that leaves me with 2x plus 1. Okay, so that's going to replace this part right there. This is 3x to the third. This is 3x squared. I need to multiply that by x to make it x to the third. Okay, so they both need 3's, they both need x to the thirds, and they both need 2x plus 1. So I'm going to have to multiply this one by 2x plus 1. So remember, whatever I multiply the denominator by to change the denominator of the fraction, I got to multiply the numerator as well. So both fractions have a 3x to the third, and they've got a 2x plus 1. So I've got 4 times 2x plus 1, and I'll simplify that here in a little bit, and x times x, which is x squared. So I'll do a little distributing. That's going to give me 8x plus 4. I'll rewrite it in x squared plus 8x plus 4. Now, that's not factorable. The numerator is not factorable. Sometimes it is. There's my denominator. Don't worry about multiplying this back out, because eventually I would try to factor that to see if anything cancels out. But there you go. That's them added. Let's see here. Let's try this again. I'll factor x squared minus 9 because I know that's a pattern of x plus 3, x minus 3. So now I'm hoping that this one has x plus 3 in it, and it does because it's x plus 3. And it's actually another factor of x plus 3. Again, I'm just factoring both denominators. This first fraction had 2 x plus 3's. This one only has 1 x plus 3, so I'm going to multiply it by another x plus 3. Maybe I should do that in another color just so you can kind of see that I added another x plus 3 to here. And this one's got 2 x plus 3's, but it doesn't have an x minus 3. So if you notice, both denominators have x plus 3 twice and x minus 3 once. Now, whatever factor I put with this first fraction, I got to multiply the top as well. And I got to multiply the top as well here. Okay, so to do this, I'm going to have to FOIL first, outside, inside, last. Let's see, I'll go over here, and I think it's x squared minus 3x plus x minus 3. And then over here, I'll distribute a minus 1, so minus x minus 3. All over my common denominator of x plus 3, x plus 3, x minus 3. Now it's all about combining like terms. So like I've got the minus 3x, the plus x, and the minus x. And that's going to give me minus 3x. So I've got x squared minus 3x minus 3. Again, I'm going to try to factor the numerator of the fraction here, but there aren't factors of negative 3 without be to that middle, so it's not factorable. And you might see this x plus 3 to the second power. That's just because x plus 3 was twice, and x minus 3. Again, do not multiply 3. You can leave it in factor form just like that. Okay. But those expressions I added or put into the fractions were the necessary factor I would need to add to each fraction to get myself a common denominator. Okay, let's try that again. I'll go back to my red. Factor first, so x minus 3, x plus 3. Okay, the other one's factor. I'll go with my blue. So remember, they have to have the same factors. So this one's got an x minus 3 and an x plus 3. This one has x and x minus 3. So what this one's missing is the x plus 3. And whatever I do to the bottom, I got to multiply by the top. This one's got the x minus 3. It's got the x plus 3. It's just missing another factor of x. So on the numerator, I've got x squared. Ooh, big old lefty hand. There we go. Draw. There we go. So I got x squared. Okay, distribute a positive 3. All right, it's a plus 3, so positive 3 plus 3x plus 9 all over x, x minus 3, and x plus 3. Okay, and I got to try to factor the top, but nothing factors out, so I'm left with that. Okay, the biggest thing is you need a common denominator first before you add any fractions. It's the same type of problem that you would have done with any other fraction with numbers. Now it's just with polynomials.